My name is Elena, and today my topic of the presentation is the microservices and Docker. Let me start. At first, this is my outline. We are going to talk about microservices, but to understand what it is and how it differs from the regular application and regular type of applications you usually are writing, we are going to talk at first about the old school model of writing applications, and then we are going to talk about the microservices and how they work. Some technical details will be given, how we are coming from regular applications to the microservices type of architecture. Then we will be talking about containers and Docker containers and some final words just to summarize whole the presentation. Okay, we will be starting from talking about the monopolic application. So the monopolic architecture is considered to be a traditional way of building applications. It is built as one single unit. Usually, such solution comprises a client-side user interface and also the server-side application and some database. The monopolic applications have a number of strengths. So the first of them is the less cross-cutting concerns. So in monopolic application, functionality concerns only lies in one application, so it's easier to handle them. Also, they are easier to debug and to test. Monopolic applications are much easier to deploy, so when it comes to monopolic application, you do not have to handle many deployments as in microservices, so it's very easy, just write the application and deploy it. Well, they are also much simpler to develop. As long as a monopolic approach is a standard way of building application, engineering and testing teams are used to this type of application and they know how it works. So these all advantages come to the rules. Why should we still use the old school monopolic architecture? So if you have a simple application, small team, and also you do not have much expertise in writing like a microservices application, you should use the monopolic architecture. Do not make it complicated, just simplify if you have. Still, it has some disadvantages we'll be talking about now. So the first one is understanding. When a monopolic application scales up, it can become too complicated. It is very complicated to understand what is going on inside your huge code. Also, making changes in the big monopolic applications is very hard. If you have large and complex application with tight coupling inside it, any code changes will provide changes in the whole system, and sometimes whole system will crash. It is like a very huge disadvantage if we're talking about big applications. Also, the next disadvantage is scalability. So you cannot scale components independently. So you need to change the whole application at once, even if you need to change only one small module. A barrier for a new technology. So if you are using some technology and suddenly the new type of technology appears, you cannot easily transfer to this new technology because you need to rewrite the whole application at once. Sometimes it is quite hard to do this. That's why you should not use the old school monopolic architecture if you are writing the evolutionary application with a number of different functions and you need to develop this application ongoing. So in this case, you should consider to use the quite new architecture, which is called the microservices architecture. So the microservices architecture breaks into a collection of smaller independent units. These units carry out every application process as a separate service. So all this service has their own logic inside and the database connection, and they perform their specific function. Within the microservices architecture, the entire functionality is split into independently deployable modules, separate ones, with communication with each other independently and outside the application. So they communicate to each other as separate modules. This type of architecture has a number of strengths. So at first, independently components. These components are, again, they are deployable and updatable independently, and they not influence each other and not interrupt working of each other. It is easier to understand such architecture because you have the number of separate applications with one simple task they are doing, and well, you can clearly see the goal of each module of each application in the microservices architecture. If we're talking about the microservices architecture, the next advantage is the better scalability. So the entire process of building, of scaling the microservices application is more cost and time effective than a monopolic architecture. The next advantage is flexibility in choosing the technology. So you can start working with one technology and then write your next module using the other type of technology, using even the other programming language. The one part of microservices can be applied in JavaScript, the next one in Python, the next one in C#. So the way you want it, it will be working. And the final advantage is the higher level of agility. So any flaw, any bug in one part of microservices application in one module do not affect the other modules. So the whole application will be still working. Okay, and so why you need to choose these complex microservices architecture? If you have a complex and scalable application with a number of different functions, you definitely should choose the microservices architecture. But well, not for all application, not for all project it works, because microservices architecture still has a number of disadvantages. The first one is extra complexity. So you have the number of different separate modules. They need to communicate to each other. They need to be deployed separately and independently. And sometimes it is more complicated when comparing to the case if you're writing the whole application. You need to just to deploy it, and that's it. Okay, the next disadvantage is the system distribution. So microservices architecture is a complex system of multiple modules. You should establish communication between these modules very carefully. Cross-cutting concerns is the next disadvantage. When you're creating the microservices application, you have to deal with the number of cross-cutting concerns. And also testing. When you have microservices, the number of tests you need to provide will grow proportionally to the number of modules you use. That's why, like a small outcome from this explanation, you should remember that without proper skills and knowledge in building microservices, you should not proceed to this type of architecture. So if it is your first application, you should not consider, maybe you should not consider using microservices, but still, it is more beneficial for a complex and evolving application. It offers effective solutions for handling complicated systems of different functions and services within one application. Okay, so yeah, for example, if you have the very complicated architecture on the slide, you can see the example of, I think it's Netflix system. Yeah, great number of different services, they all interact to each other, they all are connected. So in these cases, yeah, you should consider it. Now we will be talking about several steps, how to proceed from the traditional macro services, well, the traditional architecture application to the microservices application. The first step to proceeding to microservices architecture, of course, it starts with people. You should cultivate a solid foundation, the team of people who are working in such architecture, who know how it works, who are planning to build the whole complicated architecture of the future application. Then you should begin with API. Simple math, the one microservices starts with one API. So you do not need to create a number of different APIs if you are starting with one module, one API. The next tip is ensure the separation of concerns. Each microservices must have a single defined purpose. So if you start feeling that your microservices application growing too big, maybe you should consider to split it to different services. This is the microservices way of thinking. The next step is the production approval through testing. You should test each module of microservices application separately. By the proper testing of each module separately, you will be making the whole developing process easier at the final step. And the next step is automate deployment. Automate code analysis, security scans, pass-fail testing, and other possible process in your microservices structure should be automated. It will make the whole development process easier. And then the final step is using the containers. So now let's consider what are containers at all. The standard architecture of containers is presented on this slide. So the container is a standard unit of software that packages up code and all its dependencies. Containers eliminate one of the classic causes of software distribution failures, which is this application doesn't still work on my machine. It works on the developer machine, but it does not work on my machine. This is usually due to subtle differences between two machines. These differences can be mismatched dependencies version, or other configuration incorrectnesses. Containers solve this problem effectively by creation of static reproducible package with everything you need just to run your application code in a container. Okay, so here are the main advantages of containers. At first, they are lightweight. Containers share the machine kernel, eliminated the need of a full operation system instance per application, and making container files small and easy on resources. Also, they are portable and platform independent. Containers carry their dependencies with them, meaning that software can be written once and then run without need to be reconfigured across laptops, clouds, and on-premises computing environments. Also, they support modern developments and architecture due to a combination of their deployment portability, consistency across platforms, and their small size. Containers are ideal to fit for modern development and application patterns such as microservices. So also they improve utilization. Containers enable developers and operators to improve the memory utilization. So containers are small and lightweight. It makes them a good match for microservices architecture. They fit there very well. This is a development approach that breaks an application into small components and they are independent as possible. Each of these separate applications is a separate container. Sometimes you need all the containers together and not as a single application. In this case, you should use a special system to manage the containers. Now we will be talking about the Docker system. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so you can deliver software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. Docker provides the ability to package run an application in loosely isolated environment in a container. You can easily share containers while you work and be sure that everyone you share your container, your application with, gets the same container and works in the same way. Okay, the Docker system has a number of advantages. Again, the fast, consistent delivery of your application. It is similar to the container system, so it is the stimulus. It makes the development lifecycle easier by allowing developers to work in standard environment using local containers which provide your application and services. It is responsive and scalable. Docker containers-based platform allows you to make a highly portable workloads. They run on a developer's local laptop or in a physical or virtual machine in data center or on clouds or in other types of mixing environments, whatever. Also, Docker containers provide running more workloads on the same hardware. Docker is perfect for high-density environments. For small and medium deployments, there you need more to do more with fewer resources. So this will help you to build your microservices application. Now, what about the architecture? Usually we have the Docker client, Docker host, and registry. The Docker client is the primary way that the Docker users interact with the Docker. So you have a number of commands. The main of them are Docker build, pull, and run. Using these commands, you can interact with the Docker host. Docker build command reads the Docker file and builds the image. The Docker pull command downloads the image from the Docker registry. By default, Docker downloads images from the public Docker host repository, but you can create your own repository and configure Docker to work with it. And the Docker run command takes the images and deploys into a computer. This was about commands, and let's now understand how the whole system works. So we have the Docker daemon services on a host. So the Docker daemon listens to the Docker API requests and manages Docker objects such as images, containers, networks, and volumes. Daemon can also communicate with other daemons to manage Docker services. Docker registries is the store for Docker images. Usually it is a public registry that anyone can use, and the Docker is configured to look for images in the Docker hub by default. Images that are stored in the Docker registry is a read-only template with instructions for creating a Docker container. Often image is based on another image or some additional customization type of image. For example, you may build an image which is based on Ubuntu image, but installs on Apache web server and your application, as well as the configuration details needed to make your application run. So again, the image is just read-only template with some instructions how to build a Docker container. Well, container, we already know what it is, but still, a container is the runnable instance of the image. You can create, start, stop, move, or delete containers using Docker IP or a Docker client. You can connect to container using one or more networks, attach storage to it, or even create a new image based on the current state of the container. The container is defined usually by its image, as well as any configuration options you provide additionally to configure the container. To build a container from downloaded from the registry image, you use the Docker file, the file with instructions how to build the container from the image. Inside the Docker container, you have your whole application with all installed dependencies running. So the separate microservices program can be run in one Docker container, and then it stops. You can just close the Docker container and then open it again if you need it using the Docker image from the database. Well, sometimes you need to open a number of different containers on one machine at one time. For this case, you can use the special Docker Compose tool. It is a tool for defining running multi-container Docker application. With the Docker Compose, you use configuration file, your own configuration file for application services. Then the single command you create and start all the services of your configuration at once. Well, to learn about Compose, let's see a number of its features. So using Compose is basically a three-step process. At first, you should define your application environment with the Docker file, so the file with instructions, so it can be reproduced anywhere. So you're making Docker file with instructions. Then define the services that make up your application in the Docker Compose format, so they can be run together as an isolated environment, as a container. And then just run Docker Compose up with the Docker Compose command and starts running your entire application. This is like the whole very simple 3 steps to work with the Docker and create your own microservices application using Docker containers. Well, and now the main outcome of the presentation, the containerization Docker the containerization Docker containers are very popular terms used invariably by all the people who are working with code around the globe. It offers high flexibility in usage. Any time of complex applications can be containerized, and it is very easy. It has a number of updates and upgrades on deployment and can be intercharged easily. The Docker can be built locally, upgraded to be deployed to the cloud and run anywhere. The container replicas can be created and scaled easily and increased with efficiency. On the fly, Docker container services can be stocked vertically. I hope you understood the main idea of using microservices we have of Docker containers. It is very easy and has a number of advantages. And well, if you are trying to build a complex and big application, please read about Docker containers, and the whole microservices architecture. Have a nice coding experience, and goodbye.